Now, if you look at this chapter, okay, this chapter is known as carbonyl compound. Okay, these carbonyl compounds, okay, they have this structure C double bond O, and then they can have R group and another R group. Okay, this is going to be double bond carbon, double bond O. That is going to be the carbonyl group. Okay, so if you have, if you have carbon double bond O, R1 and R2, which is going to be the R is going to be, imagine carbon, the alkyl groups. Okay, therefore it's going to be ketone. And if we have carbon double bond O, one side is hydrogen and another side is R1. Okay, this is going to be known as aldehyde. Okay, this is very important. Okay, so we are going to learn about carbonyl compound. Carbonyl compound is divided into ketone. It's divided into aldehyde. And let's look at how you can write down in terms of structural formula. For example, if I want to actually write down CH3, okay, C double bond O, and then C like this, okay, how do I write it down in terms of structural formula? Okay, please do not write them down in terms of molecular formula. Okay, we want to see, okay, see it clearly. So how do we do? Okay, we write down, even when you're writing equation, okay, we write it down in structural form: CH3CO, CH2, CH3. Okay, just follow, quite simple. And you can see that CO, okay, that's an indication that it is going to be ketone. Now, if I have an example, okay, of aldehyde, okay, so if I have something like this, how do I write down? Okay, in form of structural formula, it's going to be CH3, CH2, C, and then you see OH. Don't go and write down OH because OH is going to be alcohol. Okay, so write it down as HO. This is going to be an indication that this is going to be aldehyde. And naming part, okay, is quite easy also. Okay, you don't need to know in detail. Okay, but anyway, 4 carbon, so it's butanon. Okay, butanon. Okay, okay, butanon. Okay, I think no need to know detail about it. Okay, in this one, 3 carbon, so propanol. That's about naming. Yeah, so now, okay, I will just erase this. Okay, coming back to what we have learned, okay, in the class based on your investigation. Now, so based on the investigation, how do we prepare aldehyde and ketone? Now, we prepare aldehyde and ketone, okay, using, okay, I think the only way that you can prepare them is going to be if you're using aldehyde, okay, then you can prepare it using primary alcohol, oxidized, okay. If you are preparing, like for example, from something else, like for example, carboxylic acid, okay, then you can do reduction. Okay, but now let's say focus on alcohol, for example. Now, for preparation of ketone, okay, for preparation of ketone, then you go and take secondary alcohol. Okay, so you see primary alcohol, okay, you need to know that when you oxidize them, okay, primary alcohol, they will change into aldehyde and will be further oxidized to become carboxylic acid. Secondary alcohol, they will be oxidized to become ketone. And tertiary alcohol, okay, they cannot undergo oxidation, no oxidation. Okay, so please remember that. Okay, so now, okay, the only problem over here is how do we prepare aldehyde? Because, okay, the primary alcohol, okay, when you oxidize, you are going to have aldehyde, but this aldehyde can be converted into carboxylic acid. So you need to be very careful, okay, not to convert them into carboxylic acid. So if you want to prepare, okay, will be set up will be something like this, okay. But the thing is, you need to heat them gently, okay, primary alcohol, yeah, heat them gently. It is also like some sort of a heated in reflux, but heat them gently, and we are going to add Okay, so it means your primary alcohol will be there, and we are going to add, okay, so this one I'll put as alcohol, okay, and I am going to add the KMnO4 acidified potassium manganate, okay, drop by drop, okay, drop by drop, and you are going to distill immediately. Okay, so distill immediately, it means because, okay, because aldehyde, okay, has lower boiling point compared to alcohol, okay, we are going to be able to distill them immediately. So we do not change them, we do not just use heated under reflux just like that, okay, because I want to prevent the aldehyde to change into carboxylic acid. Okay, so that is how you convert to aldehyde. How do you get aldehyde? But if let's say you want to form from alcohol to carboxylic acid, what we need to do? Then you just do normal heat under reflux. No need to add drop by drop. No need to distill immediately. Just use the normal heat under reflux, and then you will get complete reaction. Primary alcohol will change to carboxylic acid. The important thing that to notice is if there will be a positive reaction, which is going to be potassium manganate, your oxidizing agent. So if you're using potassium manganate, okay, your purple color, okay, purple color will change into colorless. So it will decolorize the purple color. Okay, if let's say you are using potassium dichromate, okay, instead of acidified potassium manganate, you are going to have a different color changes, which is going to be orange will change into green. Okay, so please take note of all this. Okay, purple color is because of MnO4 minus. Colorless is because of Mn2 plus. Okay, orange is because Cr2O72 minus. Green is because Cr3 plus. Okay, please go and refer to our redox reaction and so on, how to write equations and so on. Okay, but now, okay, what I want to teach now is if I have secondary alcohol, you no need to worry. Okay, no need to put drop by drop. I think just it will be just changed into ketone. Ketone can be further oxidized. Okay, so you have all that. Now, what I want to add on over here is about writing equations. Okay, this is very, very important. Let's say, for example, now I have a primary alcohol. I want to change into aldehyde. Okay, so my primary alcohol, let's say I have this as my primary alcohol. Okay, CH3. Okay, this is my ethanol. Okay, and I'm going to try to oxidize this. Okay, and I'm going to use this O, and then I'm going to oxidize this to become aldehyde. So how do I write it down as a form of equation? I think even your assignment or your investigation has questions on this. How do I do this? Okay, so in order to do this, okay, what you do is going to be you have this O, and then you just put, okay, this one, okay, I'll just put it down over here, H and H. Okay, you want to change it into aldehyde. Okay, what you do, this O from here, okay, they will come over here. Okay, once they go there, the bond over here will be broken. Sorry, the bond from here will be broken, okay, to give you water. So you are going to get water, and you are going to have CH3, CH, double bond O. Okay, you're already having the aldehyde. Now, how do I write in form of equation? Okay, you write down as, okay, CH3, okay, and then CH2OH, the alcohol. You just need only 1 mole of oxygen, so I just put 1 mole of atom of oxygen, and it will give you CH3. How to write aldehyde? You write down as CHO plus water. Simple as that. Okay, now how do I change? Okay, how do I oxidize this aldehyde to become carboxylic acid? Now it's way more simple as well. Okay, if I have this aldehyde, I want to further oxidize again, so I just need to have only 1 mole of O. Okay, what will happen? They will come at this position. Okay, so you are going to get the carboxylic acid. Okay, so it means that if I write down equation, it will be CH3. I'll just rewrite CH3 CHO with 1 mole of O. It is going to give me the carboxylic acid. So CH3 COOH. The O came in front of the H. Okay, and then no H2O. Okay, it means it's just add. Okay, now is there a way to write down the equation from primary alcohol all the way to carboxylic acid? Yes. Okay, what you need to do, you combine equation number 1 and you combine equation number 2. Okay, how to get it done? You see the similar thing is this one and this one. When you combine left and right, they can cancel. So how do you write the equation? Okay, the equation should be CH3 CH2OH plus 2 moles of O. It will give you CH3COOH plus H2O. If you want to write down for the entire equation, okay, means you're converting primary alcohol to carboxylic acid. Okay, so that will be the way. Okay, the way to actually oxidize that. Now, how to write? Okay, since we have written in this way, how about secondary alcohol to ketone? Then it's going to be way simpler. Okay, you see, yes, secondary alcohol. I'll give you one example of secondary alcohol. Okay, COH, and then let's say another C, CH3. Okay, CH3, and then H. This is a secondary alcohol. And I want to oxidize, okay, secondary alcohol to become ketone. So I just put O. So now how many O do I need? Okay, similar way, you just try. Okay, you see the O will be going here. Okay, at the hydrogen, and then the bond between here and this will be broken. And what you will have is going to be, you are going to have water molecule. And you are going to have carbon, CH3, CH3. Okay, so CH3, CH3, and then double bond O. You are going to have ketone. So in simple terms, is there a way to write down? Okay, yes. Okay, you can write it down because I want a secondary alcohol, right? The secondary alcohol was carbon, okay, with CH3, 2CH3, 2CH3, and then OH. Okay, so carbon with a hydrogen, there is one hydrogen. C, okay, C, and then H, CH3, 2, OH. Okay, so this is going to be how I represent the secondary alcohol. And then plus O, because I only need one O, and it gave me, okay, water. So I just put plus water. And then how do I represent this? Okay, this is going to be CH3, CO, and then CH3. Like what I explained to you just now. Okay, quite simple. Okay, how to write equation for the oxidation and how to write equation for the oxidation of primary alcohol to aldehyde, aldehyde to carboxylic acid, and so on. Okay, so this one done, yeah. Okay, this note later I will share it to you. Okay, but now, okay, let's look at, okay, if we can have, okay, oxidation, primary alcohol to become aldehyde to carboxylic acid, secondary alcohol can be changed into ketone. Of course, we can have a way how to change this ketone, how to change carboxylic acid or aldehyde back to its alcohol. Okay, so we can actually do that. So when we do this, okay, so we can use reducing agents. Now the reducing agents in our chemistry, there's so many reducing agents. Okay, there are so many reducing agents. The popular one is going to be LiAlH4. Okay, LiAlH4 is very, very reactive. So it is not even kept in water. It's kept in dry ether. Okay, so it's like organic solvent. Yeah, so it's kept in dry ether. Another one, okay, is going to be NaBH4. Okay, NaBH4. But this one still okay. No need to actually keep it in dry ether. Okay, so But do remember LiAlH4 is a very good reducing agent. Okay, very good reducing agent. So when we look at, let's say, for example, in your syllabus, they say, okay, I need to know how to reduce aldehyde and ketone. But in our previous chapter, we have learned about reduction of carboxylic acid. Okay, so now I'm going to combine all together. Okay, so if you look at primary alcohol, they will be oxidized to become aldehyde, and aldehyde can be oxidized to become carboxylic acid. Okay, so I'm going to actually break it down into, like for example, I want to change carboxylic acid to aldehyde. Okay, and then aldehyde to primary alcohol. What can I use? Okay, what can I use? So of course, okay, carboxylic acid to aldehyde, you can use, okay, any of these two. Okay, a very strong one or a weak one, doesn't matter. You can use LiAlH4 in dry ether or NaBH4, still fine. Okay, no problem. Now, if I want to change aldehyde to primary alcohol, the same. Doesn't matter, LiAlH4, or you can use NaBH4, no problem. Okay, no problem. But, okay, if you want to change carboxylic acid to the primary alcohol, then you have to be very careful because you're bypassing aldehyde. You cannot use the weak reducing agent. You must use LiAlH4 in dry ether. Okay, it means all of this is in dry ether also, yeah? I'll just put DE. Okay, so cannot use NaBH4. I'll just put cannot NaBH4. Okay, so this is important. Okay, one thing that is important. Now, if you put as secondary alcohol, it's going to change into ketone. Okay, ketone cannot be further oxidized. Okay, so it means it's stuck in the some sort of in the middle. So if you want to change ketone to secondary alcohol, you just follow like what we did over here. It means you can use LiAlH4 in dry ether, or you can use NaBH4, no problem. Okay, no problem. Okay, now what is another important thing that we need to know? We represent reduction, okay, in terms of this. So you need to know how to write down equation using that. Okay, so how do we write down? Okay, let me actually give you one example. If let's say carboxylic acid, I want to change it to aldehyde, I need to write down an equation for that. Okay, and then I need to change aldehyde to primary alcohol, I need another equation. And I will give you another equation for carboxylic acid to alcohol. So I'll just show you over here. Okay, so let's say now I want to actually reduce carboxylic acid. So carboxylic acid, I'll write down carboxylic acid, and I want to change this carboxylic acid, and I want to reduce. Okay, carboxylic acid, I want to reduce to become what? I want to reduce it to become aldehyde. Okay, so if I want to reduce it and I want to make it into aldehyde, what I need to do? Okay, guys, sorry, yeah, just now. So now, okay, you see here, I want to actually find out how can I reduce, okay, reduce using this carboxylic acid to become aldehyde, for example. Now, if you want to reduce to become aldehyde, you see what happens here. So I'm going to actually remove, okay, I am going to put, okay, put the hydrogen, okay, over here. Okay, I'm going to put the hydrogen over here. And I'm also going to put the hydrogen over here. Okay, you see what happens. Okay, if I do that, it means I'm going to put hydrogen here. Okay, and I'm going to put one hydrogen over here. And what is going to happen next is going to be, you are going to remove, okay, the OH with this. okay, to give you water. So it means I will get plus water. How many moles of hydrogen that I use? I use 2. And I am going to have H3C and then C double bond O and H. So if I write down, okay, the equation, I will write down as CH3, okay, COOH, okay, carboxylic acid, plus 2H, and I'm going to get CH3, CHO, okay, it's aldehyde, plus H2O. So I already wrote for carboxylic acid to aldehyde. Now, how about aldehyde to alcohol? Okay, let's see. This is aldehyde, yeah? So I'll write down H3C, C double bond OH. I want to find a way, how do I change this into alcohol? Okay, how to change this into alcohol? Quite easy, okay, very simple. You just need to put the hydrogen here, okay, and you just need to put another hydrogen there. Okay, so it means you need only 2, okay, and then there is no bond breaking, so it means there is no water coming out. So you are going to get CH3, CH2, okay, CH2OH. Okay, this is going to be, if let's say I want to write down in form of equation, yeah, I think you know CH3, CHO plus 2H gives you CH3, CH2OH. Writing down equations. Okay. How to write equation if I want to actually change the carboxylic acid straight to the alcohol? Equation number 1, equation number 2. Combine them. Okay, combine them. So if you combine them, it means that this one and this one will cancel left and right. So you are going to get CH3COOH plus total 4H to give you alcohol and water. So I taught you all the things, okay, related to what you can do, okay, to write the equation. The same thing applies, okay, when you are having, the equation, like for example, ketone, you want to change it to secondary alcohol. So let's look at ketone, like for example, C double bond O, CH3, CH3, for example, okay. Now I want to actually oxidize them, I want to reduce them, okay, into the alcohol. So what I am going to do, okay. Now, if I want to reduce them, okay, quite simple. Okay, just put the hydrogen, okay, over here. Okay, hydrogen here, and then another hydrogen here. So there is no water going to come out. Okay, you are going to get straight away alcohol. So you are going to get CH3, CH3OH, and you can see it's a secondary alcohol already. Okay, so if I write down the equation, how it will look like. So it will be CH3COCH3, okay, plus 2 moles of H, and it will give you CH3 CHOH. So it means I want to actually write down in terms of alcohol. I think different ways can be used. Okay, I just use this carbon, hydrogen, bracket CH3, that's 2, and then OH. Okay, this is going to be the equation that I can write, okay, to show that, okay, the reduction of ketone to secondary alcohol. Even can you understand basically all the equations, how to write and so on?
So far, yeah.
Yeah, so I think the important thing, don't get confused with a lot of things that I show over here. I think better to see how did I end up using my displayed formula. How do I put the H? When do I remove? When I don't remove? Okay, like for example, we know from carboxylic acid over here. I want to get, okay, I want to get aldehyde, okay. Of course, you need to remove the water, okay. Then only you are going to get carbon double bond O, okay. So please actually take note how it is done, okay. But generally, okay, this one, okay, all this reduction of aldehyde and ketone, and even I think reduction of carboxylic acid I've covered over here. Later I'll share with you these notes. Okay. Now let's look at what we are going to learn today. Okay, this is very important. Okay, this is very, very new. Okay, so the very new part over here is going to be, and we are going to learn about the mechanism of the reaction. Okay, so I'm not going to give you the mechanism of the reaction straight away. Okay, I will just discuss with you what might happen first, then maybe we can discuss about what is the name of the mechanism. Okay, now in this chapter, okay, we are only going to learn reaction of aldehyde and ketone with only one thing. Okay, you see, for alcohol and so on, we have learned many things. Okay, but the reaction with aldehyde and ketone in your syllabus is limited. The reaction is only with HCl. HCl, and this HCl is produced in situ. I hope you remember what is the meaning of in situ. You put it in the same reaction vessel. What do you put in the same reaction vessel? You produce HCl by reacting NaCN with dilute H2SO4. You are going to get HCl plus NaHSO4. So this HCN comes from that. Okay, that HCN comes from in situ preparation. So this one is separate, yeah. So I'll just put it as separate. Okay, now that is going to be HCN. So I'm going to see, let's see what is going to happen if I have a ketone over here. Okay, let it be ketone, let it be aldehyde. The reaction is almost the same. So the CN, okay, the CN is going to be coming, will be attacking this part. Okay, the CN will attack this part, and it is going to be giving you CN over here. And then, okay, another part, okay, is going to be the one with O. The H will join with the O to give you OH. Okay, now, so can you roughly understand what's happening, Christopher? So basically you separate into two. The CN, okay, comes over here. The double bond is broken. And then this one will join together with H. And you are going to get this R and R stays. CN came in, and then you have OH. Can you see, Christopher? Now, so now I'm going to actually ask Christopher another question. If I ask you to suggest a mechanism for this reaction, how do you suggest the name of the mechanism? Now, is this involving nucleophile or electrophile? Is this a substitution or addition? Let's actually go for the easy question. Is it a substitution or addition?
It's addition.
Yeah, correct. Okay, you already have half correct over there. Addition. Now, just now I said the CN goes where? Christopher?
The carbon.
Carbon.
Is it
carbon is bonded to oxygen. So oxygen is electronegative. They always withdraw electron, or they donate electron, Christopher.
Which one? The carbon.
Oxygen.
Or the oxygen they take.
They take. So when they take, oxygen will become delta negative. What will happen to the carbon? Delta positive or delta negative?
It's delta positive.
Delta positive. Now the CN goes to
right?
delta positive. CN is what?
Then it's delta negative.
Yeah, CN is delta negative. So CN is a nucleophile or electrophile?
So nucleophile.
Nucleophile. So this is nucleophilic addition. Okay. The mechanism is going to be different. Okay, now we are introduced to a new mechanism, nucleophilic addition. So let's look at the mechanism of the reaction. How do we represent them using curly arrow diagram? Okay, so how do I use curly arrows to represent them? Quite easy. Okay, if you have this molecule, like what I said, oxygen is more electronegative. They are going to withdraw the electron from the double bond, okay, to there. So this is delta negative. This carbon is going to become delta positive. Now this Cn minus, okay, where it is going to come, okay, it can come either from NaCN or it can come from HCN, doesn't matter. Okay, it is going to be, you are going to have a lot of Cn ions. Okay, and these Cn ions, okay, they are going to be directly from here, they come and attack the delta positive. Okay, let's wait until it shows over there. Hold on, yeah. I'll share my screen again. Okay, you can see what I have written over there. Okay, you see, okay, the Cn is going directly to delta positive, the carbon over there. Okay, so what is going to happen? You are going to get intermediate. What is intermediate? Let's see. I'll draw carbon. You have R, another R. Okay, Cn came in. I'll just put Cn. And then now, okay, from the double bond, okay, the electron went to the oxygen. So it means that you are going to have O. Okay, maybe to show that the electron went to oxygen, I put another like this. And then maybe you want to put negative. Okay, this is intermediate because the electron went there, okay, towards the oxygen. So I'll just put as intermediate. Okay, now once you have this intermediate, okay, this intermediate, you are going to have, okay, the reaction, okay, with, okay, yeah, if I write down the intermediate again, yeah, and then Cn. Okay, now what is going to happen now is, okay, now earlier, remember, I'm getting the HCN. Okay, I'm forming the HCN. Okay, earlier the nucleophile, okay, it's already reacted, but now from the molecule of HCN itself, okay, how further reactions can happen? Okay, this one, okay, because of the presence of the electron, okay, the electron pair or the lone pair at the oxygen, they are going to actually move and then attack the hydrogen. Okay, so when they are attracted towards that hydrogen, okay, what happens? Okay, the electron or the electron that is being shared between hydrogen and Cn, they are going to be pushed towards Cn. Okay, it means basically just take it as H and Cn is going to break. Okay, so the electron will go there. Okay, so what causes the breaking or what causes the fission? Okay, this intermediate is going to actually cause that breaking. Intermediate. Okay, now, so what happened now? They join. Okay, this one O and H, they join. Okay, so what happened is you are going to get carbon R. I put the Cn over there. I just put at the bottom OH plus Cn dot minus. Okay, so this product that you have, okay, over here. Now, anything that has RCN is called nitrile. Okay, nitrile. And you just follow, this is carbon number 1. Okay, automatically this is a nitrile. You are going to form a nitrile. At carbon number 1, at carbon number 2, okay, this is carbon number 2, that's OH. So that's why it's called 2-hydroxy nitrile. Okay, at carbon number 2. It means the product that is always going to be formed is going to be 2-hydroxy nitrile. Okay, can you understand this, Josh?
Yes, sir.
Okay, now you do the same thing if it is going to be aldehyde. Okay, if aldehyde, what will happen? Hydrogen, just change it to hydrogen. Just change this into hydrogen. Just change this into hydrogen. Just change this into hydrogen. Okay, once you get that, even in that sense also, okay, when I name, okay, you can see it's going to be 2 carbon. Okay, so carbon number 1, carbon number 2, this is also 2-hydroxynitrile. Okay, in your textbook they say even that 2 is not necessary also, but doesn't matter. Okay, doesn't matter. Okay, but it's, you are going to get 2-hydroxynitrile. Okay, this mechanism of this reaction is very, very important. Okay, please go and read about this. Now let's look at the next part, okay, which is going to be testing. Now, for testing of carbonyl compounds, there are 4 testing. Okay, there are 4 testing. Today we are only going to learn 3. Okay, with 2,4-DNPH, with tolerance region, and Fehling solution. There's another one, okay, but we leave it for next lesson. Okay, so we are going to actually look at what is going to be like, for example, what is the use. Okay, now this 2,4-DNPH, you can use the abbreviation, no need to know the full name. Okay, it's dinitrophenylhydrazine. Okay, but doesn't matter, DNPH will do. Okay, now the positive reaction is going to be, it will give you a deep orange precipitate. So deep orange precipitate will be for what? 2,4-DNPH will be able to detect carbonyl compounds. It means if you have, okay, if you have ketone, if you have aldehyde, you are going to get a positive test with 2,4-DNPH. It means that when you mix ketone and aldehyde with this compound, you are going to get a positive result, which is a deep orange precipitate. Now, what is required? You must know how to draw 2,4-DNPH. You must know. Okay, I will draw again for you. Yeah, so you see here, this is going to be, okay, a benzene. Okay, later in A2 you will learn, in JC2 you will learn more detail about this. 2,4-DNPH. Okay, you just take it as, okay, you just put NO2. Okay, basically it's NO2. Okay, and then, okay, imagine this is position 2, 3, 4. Okay, so this is going to be 2,4. Okay, it's okay already. So 2,4-dinitro, already the dinitro is done. And then at this part, put nitrogen, and you put hydrogen, you put an H2. You must know how to draw. You practice at home. Okay, memorize only. Okay, practice at home. Now, this 2,4-DNPH, why we need to know the diagram? Because you should be able to write down the equation. Okay, I'll write down the equation. What will give you the deep orange precipitate? Okay, so if I bring this, okay, and then I put it here. Let's say I'm going to react this, okay, with any carbonyl compound. Let it be just let's say maybe propanol. Okay, let's say I'm going to react with propanol. C double bond O, CH3, CH3. What will happen? Okay, now the reaction is very simple. The 2 hydrogen from the nitrogen here, okay, 2 hydrogen from the nitrogen over here, they will combine with the O over here, and they are going to give you water, and the resultant product will be, okay, I'll just draw, nothing changed here. Nothing changed here. Nitrogen, hydrogen. Okay, so hydrogen, I'll just put the hydrogen down. Okay, so this hydrogen, yeah, and then this nitrogen now will be bonded to carbon, and this carbon is bonded to CH3 and CH3. I'll just put CH3 here, and then I put another CH3 over there. CH3, CH3, another one. Okay, so you are going to have, okay, so now I just want to ask you, nitrogen. Okay, I think I made a mistake. This nitrogen, yeah. Okay, so nitrogen and hydrogen done, and then there is another nitrogen. This one, there's another nitrogen, and then this nitrogen is bonded to carbon, and then CH3 and CH3. Okay, I just want to ask you, is this complete? Maybe Megan, did you see anything wrong over there? Something is wrong there. Even, did you notice anything wrong there? One nitrogen can form how many bonds? Megan? One nitrogen? Yes, okay. One nitrogen can actually form 3 bonds. Okay, so it's supposed to be, you see, 1, 2, 3. Okay, 1, 2. Each carbon supposed to form 4 bonds. So what is missing? This one is missing. You need to add the double bond there. That's the only thing that you need to know. So it will give you water plus water. So it means that this structure is the one that will give you your deep orange precipitate. This is deep orange precipitate. Okay, so this is what is it called? Is 2,4-dinitrophenylhydrazone. Okay, I don't think so it's required. Okay, but you should know how to write equations. Okay, please go through this again. I will go through this again next lesson. Okay, now the next one is going to be, okay, this one, do remember, is for both ketone and aldehyde. Now, once you identify ketone and aldehyde, okay, it means once you know that they are carbonyl compound, is there a way to find out whether which one is ketone, which one is aldehyde? You can do that, okay, with these 2 tests. One is going to be Tollens region, another one is Fehling solution. The function of Tollens and Fehling solution are quite simple. They are generally mild oxidizing agent. Okay, when we say oxidizing agent, we always refer oxidizing agent as KMnO4, K2Cr2O7 acidified. These are the very strong oxidizing agents in our lab in chemistry. But okay, there are also mild oxidizing agents. Okay, the mild oxidizing agents are, okay, this Tollens and also Fehling. Okay, mild. Okay, we don't use them all the time. Okay, later we will use them, but now they just learn. Okay, they function as oxidizing agent. Now, if they are oxidizing agent, just mean if let's say Tollens region, okay, Tollens region, I already wrote down for you what is Tollens region is silver nitrate in excess ammonia. Okay, they are oxidizing agent. Now, if these are oxidizing agent, they will oxidize others, but they themselves, just mean, will get oxidized or reduced.
Reduce.
Okay, they are going to get reduced. Please remember that. So they are going to oxidize others. When they say oxidize others, I just want to ask you, between aldehyde and ketone, which one can be oxidized? Kevin, which one do you think will be oxidized?
Aldehyde.
Yes, very good. Ketone cannot be oxidized, yeah? Aldehyde. It means that a positive test for both will be aldehyde and also aldehyde. Ketone will give you a negative test. Okay, a negative observation. A positive observation. Let's see what is the positive observation. This test is also known as silver mirror test. And I'm very sure you heard about this also. Okay. You are going to have silver nitrate in excess ammonium. Silver nitrate is going to give you this Ag plus. Okay. Ag plus. So what happened? Because just now you said they are going to be reduced. So it means this Ag plus, they are going to become Ag. It means they are going to be added with electron. If you forgot about this oil rig, okay, reduce its gain of electron. Or if you still don't remember that, it's okay. You can use oxidizing agent +1 to become 0. So reduce in oxidation number. They are going to be reduction. Okay. So you see, silver ion, they are changing into silver metal. Okay. They are going to form. Okay. If you have a test tube over there, they are going to give you a silver mirror appearance. It means there are going to be silver mirror surrounding that test tube. Okay, so that is formed by Ag. Okay, this is going to be the test. Okay, for your aldehyde. Aldehyde will give you a positive test. Okay, a silver mirror appearance will be formed. Now, both of them are you need to warm them. Okay, you need to warm. Okay, you need to warm. Let's look at Fehling. Okay, Fehling solution. What is Fehling solution? It's an alkaline copper 2+ ion. Okay, alkaline copper 2+ ion. Okay, let me share the screen again. I think it stop. Okay, my iPad also almost no battery. It's not charging properly. Okay, let's try. Now, when I have copper 2+ ion, okay, the positive result, okay, it means the positive thing that I'm expecting to see is red orange precipitate, something like, okay, your 2,4-DNPH. Okay, your 2,4-DNPH is going to be deep orange precipitate. This precipitate, I think sometimes it's referred as brick red precipitate. It's darker. Okay, it's darker. Okay, so why we have that precipitate? That precipitate comes, okay, because the copper 2+ is changing into copper plus. Okay, so if you look at it, positive 2 to become plus, it means reduction. Okay, and we know this is oxidizing agent, they are going to be reduced. Okay, so basically what's going to happen? Okay, the copper plus, okay, this copper plus will join with this oxide, okay, to give you copper 1 oxide. This is copper 1 oxide. The color that you see, okay, which is going to be the brick red precipitate or red orange precipitate, is actually the color of copper 1 oxide. Okay, copper 1 oxide. What is the color of copper 2+? Let's actually ask Michelle Wing. What is the color of alkaline copper 2+? Jeffrey, want to help? What is the color of copper 2+? Frederick.
Green.
Color blue, yeah.
Yes, good. Okay, clear blue. Okay, clear blue. So you see here, from clear blue, it's going to become brick red. Okay, so the color is going to be, the observation will be from clear blue, they are going to give you a red orange precipitate or brick red precipitate. Okay, so that is going to be the observation, okay, to identify aldehyde and ketone and so on. Okay, we still have time, okay, but I will actually just go through again. Yeah, let's see what we have covered. We have covered a lot of things today. Okay, you see, how do we prepare aldehyde and ketone? I have covered all this in our investigation. I've covered the reduction also in our investigation. Okay, you just need to sharpen this. Okay, practice. Okay, but today's lesson is more towards your reaction. Okay, nucleophilic addition reaction, how to write the mechanism. But yeah, I have actually written here, maybe it's word for exploring as well. You see the nitriles, okay, the nitriles, CN. I think just now we form anything with CN, yeah, nitriles, okay. Now the CN, I want you to remember the RCN. We have learned about reactions of this RCN. One, we can actually use to form carboxylic acid. I hope you remember reaction with dilute HCl. Okay, will give you carboxylic acid. Maybe I can refresh your memory. Maybe I'll just write down RCN plus HCl plus H2O gives you RCOOH plus NH4Cl. I hope you remember this. Okay, that is going to be the one of the reaction of nitrile. Now this one is new, yeah. Okay, in your textbook also they mentioned. You will learn later also, but again, you need to know now. Okay, RCN can also undergo reduction. Remember reduction, yeah. Reducing agent, there are many reducing agents. I taught you LiAlH4 and NABH4. Okay, but now you are also going to have different reducing agent also. You can use sodium in ethanol. You can use nickel. You can use LiAlH4 in dry ether. Okay, there are three things that you can use, and it can be changed into amine. I'll show you how it can be changed into amine. Yeah. So let's say, for example, you have C triple bond N. Okay, let's say it's bonded to CH3. When I'm going to reduce using this any of these three of reducing agent, okay, I'll just put H over here. Okay, what happened? Okay, very simple reaction. Okay, if I put it as yellow ink over here, one H will come here, another H will come here, one bond will be broken, you will have another H here, another bond will be broken, and you will have another H here. So it means that you are going to get CH3, CH2, and H2. So how many hydrogen that is being used? 1, 2, 3, 4. 4. And you are going to get what we call as R and H2. This is called amine. In order for this reaction to happen, okay, you need these three regions. Okay, any of these three regions. Students, most of them, they remember this because I think very popular. Okay, LiAlH4 and dry ether. But do remember, you can use nickel. You can also use sodium in ethanol. Okay, extra, yeah, but it's not just simply extra. It is actually found in your textbook in this chapter. You must know. Okay, you must know. Okay, so now if you look at it again, okay, you can see we learn about nucleophilic addition reaction. We have learned about testing. There are 4 testing. I taught you about 2,4-DNPH. Okay, how to write the equation, how to write the 2,4-DNPH. Okay, and then how to identify between aldehyde and ketone. So we learn using Tolan and Fehling. Okay, now I have 2 minutes left. Okay, so just maybe 2 people just give your reflection on today's lesson. If let's say today you go back home, what are the areas that you might need to do a review? So maybe let's start with Audrey. Hurry up, Audrey.
The reaction of the ketone cannot be oxidized, so it doesn't react with the Fehling and Tolan region, but the aldehyde can be oxidized to form carboxylic acid.
Okay. Okay. So maybe another one person, Sharon, what are the things that you might need to have a look again when you go back home? You are at home.
How to draw the structure of 2,4 dinitrophenyl hydrazine.
Okay, very good. Okay. Anything else?
Remember the color of the precipitate form for
okay. Okay, good. Maybe someone else, maybe we can ask Michelle V. What are the areas you need to also, when you revise on your own, what are the areas you need to focus on today?
I need to memorize the equations because I'll forget it maybe.
Which equation? Is it the with O and hydrogen?
Yeah, that one, especially
Okay.
the hydrogen one.
Okay. So it means just have a look. I will share this video. Okay, just have a look where I put the hydrogen, where I put the oxygen. I know it's going to be tough, but again, if you're good at it, I don't think so you'll have problem with that. Okay, but I think there's more things to focus on. Okay, I think the like maybe even and so on. I think maybe when you see that equation and so on, it might be overwhelming. Okay, don't focus too much on that. I just want you to focus more on the mechanism of the reaction and how to actually focus, write, equations, how to use Tolan and Fehling to identify ketone and aldehyde. I think that's the main concept over here. I think writing equations, you see, even in the past year paper also, when they ask you to write equation maximum, they'll give you only 2 marks. Okay, but for analysis questions, okay, they will give you marks as high as 6 marks. So it means don't focus a lot of time in just learning how to write equations. Okay, I think there's more things that you can do, like even like Sharon said, okay, I need to go and find out more in detail about how to draw this molecule. Yes, it is super important. Okay, this one you have to memorize only. Okay, memorize. Once you memorize this molecule, very easily you can draw the equation. Just one more, just one more. I think your teacher is also here. Owen, what type of reaction do you think is this reaction? If I know the mechanism is nucleophilic addition, but what type of reaction do you think is this? Owen?
Not sure, sir. It's oxidation.
Josh? No, it's not oxidation. Josh, you want to try?
I'm also not sure, sir.
You are removing water. What type of what type of reaction is that? It's either elimination, or I think the best way to represent this is condensation. Okay, the moment you are removing water, it's like something like your esterification. Okay, but you are not forming ester here, so it means this is a condensation reaction. Okay, so please go and read all this. It's also mentioned in the textbook also. Okay, so please revise properly on this. Yeah, so I'll stop share. Okay,
Sorry, sir, what about dehydration, sir?
Dehydration. Okay, dehydration, you are removing water. Okay, it's like dehydration. I think when you are removing water from the same molecule, okay, if you are like, for example, dehydration of alcohol, you are removing water H and OH from the same molecule. But now you see, this is a reaction between molecule number 1 and molecule number 2. It's not dehydration, it's elimination. Dehydration works when you are removing it from the same molecule itself. Does it answer your question?
Well, you were lagging the whole
Okay,
time,
I will
sir.
just put it in the group, yeah? Okay, so hold on.
Yeah.
Okay. Okay, thank you guys.